Hello everyone, we're going to be talking about graphing quadratic equations today. So our first thing that we want to talk about is standard form. In that equation we will be seeing our quadratic forms in ax squared plus bx plus c. So this is where you will always see in standard form, and then our vertex form will look like this, where you have a times x minus h squared plus k. So we'll be graphing in both of these forms. Let's go over our steps for quadratic, how to graph a quadratic function first. So our first step, we're going to find the axis of symmetry. And we do that by using these formulas. So the one in, we're just going to say SF for standard form. The equation is going to be x equals negative b over 2a, and then in our vertex form we'll say VF. Then it's going to just, our x actually just equals the h, and the h is always going to be the opposite sign. Okay, so we will be practicing this. Our step 2, we're then going to use the axis of symmetry to then find our vertex. And we will use the formula, the values that we got from the standard form and vertex form. And so in standard form, our equation will, whatever the value was that we got from that negative b over 2a, will be our 1 point for our x value. We're going to plug it into our other equation to get the y value of the number. And then for our vertex form, we are going to just use the h, which will be our x value, and then the k will be our y value for our actual point. Then we are going to go ahead and fill in the table, and I will show you guys, we will be walking you guys how to do this. So fill in the table of values, and then we are simply going to graph our table of values. Okay, so let's actually use these steps. Our first step, we're going to find the axis of symmetry using this formula. So let's see what form our equation is in. So we do have our standard form equation here, negative x squared minus 8x minus 17. So we're going to go ahead and determine our vertex first, our axis of symmetry. We're going to use this is where our x equals the negative b over, so I'm going to do some side work. So x equals negative b over 2a. And we're going to now take the values. Remember, a is always the number in front of that coefficient. B is going to be the number in front of the x. The a is the coefficient in front of the x squared. So again, if you guys look at our standard form right here, we have a coefficient of x squared term, b is the coefficient of the x, and then c will be the constant while we're doing this. So let's just say our a, let's actually write out what each of these values mean. So I have a equaling a negative 1 because it's in front of the coefficient for the x squared, b equaling a negative 8 because it's the coefficient in front of the x, and our c equals negative 17. That's the constant, the number by itself. Okay, so now we're going to go ahead and actually use the b and a. So the b was the negative 8. Because you have a negative does not mean you get to just leave it because the negative is there. You have to have 2 of them. And then 2 times negative 1, which is the a. A negative times a negative is a positive, and a negative times a positive is a negative. And now simplify the fraction. 8 divided by negative 2, we get negative 4. So this is our axis of symmetry. And you need to write an equation because this is an actual line. If you guys remember that we're actually going to have a line going through the x-axis at negative 4. So there would be a line going through right here. So that's what our axis of symmetry is. Now we're going to determine our vertex. So for our vertex, we now plug in this x value into our original equation to then solve for y. So anywhere I see an x, I'm going to plug in the negative 4 to end up getting our values to see what we get for our y. And we're going to write this as a point, so negative 4, comma, and then whatever we get out of our equation here. So if I have You have to work with your exponents first, so negative 4 squared is a positive 16. Then we have to multiply it by this negative, so it's a negative 16. Then we have our negative 8 times negative 4 is going to be a positive 32. Minus 17 again. This is y equals, and then we're going to get our y equals again, where we have the negative 16 plus 32, which is with the positive 16, minus 17, we're going to get a negative 1. So now our y value of our vertex is negative 1. So now we're going to fill in the table. This is step 3. We're going to use our vertex because our vertex is always the point that looks, it's actually the turning point either direction. So we are going to use that for the center of our table to fill out. So we're going to have negative 4, negative 1. On your table, you're going to do numbers that are less than negative 4, and then on the lower half, you're going to do numbers that are greater than negative 4. So now we're just going to go ahead and plug in these values. So make sure you guys are still writing this. I'm going to get rid of our vertex here so I have some more room to actually plug in values for our graph. So now I'm going to go ahead and start off with the negative 6. So I'm going to plug that negative 6 into our original equation and solve for y. So y equals negative x squared, let me actually plug in the negative 6. So negative 6 squared minus 8 times negative 6 minus 17. Okay. So we are going to start off negative 6 squared. We get y equals positive 36. And again, you're putting that in parentheses because 6 times 6 is 36. 6 times a negative actually would be a negative 36. There we go. And then, this is a negative. So negative 6 times 6 is, negative 36. Okay. And then we get negative 8 times negative 6, we get a positive 48, and then minus 17. So we're going to go ahead and do the 48 minus 36 first, so we get 12. Minus 17, we end up getting a y equals, let me just write it here, y equals a negative 5. So now we're going to go ahead and put negative 5 here. And then we're going to go ahead and plug in the negative 5. So y equals a negative times a negative 5 squared minus 8 times negative 5 and then minus 17. I can't fit it in there. Let me get rid of this. So y equals negative times a negative 5 squared minus 8 times negative 5 minus 17. Okay, so now I have y equals negative times a negative, or negative 5 times negative 5 is a positive 25, and then you have to multiply by that last negative there. So now we have a negative 25. Negative 8 times negative 5, we have a positive 40, and then minus 17. So y equals, if we have 40 minus 25, we end up getting 15, and then minus 17. We end up getting y equals negative 2. Okay, so now we're going to go ahead and write down, plug in our values for the negative 3 and negative 2. When I plug those values in, we're going to get our new y values. So make sure that you have that negative still, even though we have negatives here. So we're going to start off with the negative 3, and then we're going to minus 8 times negative 3 minus 17. Negative 3 times negative 3 is a positive 9, but multiplied by this negative out in front is a negative 9. And then we have our 8 times 3, but they're both negative, so it's going to be a positive 24 minus 17. We're going to subtract the 9, and we end up getting 15 minus 17. So y equals negative 2. So what you guys will start seeing is that it repeats this way, and then it will start repeating this way. So hopefully our next value will be a negative 5. But let's test that out and see what happens. Negative 2 squared plus, minus, our 8 times negative 2 minus 17. So now we get negative 2 times negative 2 is a positive 4 times that negative is a now negative 4. We get positive 16, negative 8 times negative 2 minus 17. So we're going to subtract the 4 from the 16, and we end up getting our y equaling negative 5 like we were hoping we would. Okay, so now our last step we're going to do is actually to graph this. So you're just going to take the points on the graph, which are right here in this table. So we have our negative 6 comma negative 5. So that's going to be my first point, 1, 2, 3, 4, 5, 6. And then we're going to go down 1, 2, 3, 4, 5. And that's where our first graph is going to be. And then we're going to have a negative 5 to the left on your x-axis. And then we're going to go down 2. Then our next one we have negative 4 and then negative 1. So hopefully that's on our axis of symmetry. That's where it should be going. And then we have our negative 3, negative 2. And then they should be mirroring the objects of each other. So you guys can see that the point, this axis of symmetry is the mirror of it. So now we go ahead and connect our dots. This is a downward facing parabola because we had that negative symbol in front of that x squared right there. So that's what our downward facing parabolas, our sad face parabolas, because they have a negative a. Alright, we're going to do one more graph in vertex form. Again, vertex form is super nice because we get to actually use the vertex directly from the problem. So for this problem, we're going to find our axis of symmetry first. So if you remember our steps back here, our axis of symmetry was where x equaled h, and it was the opposite sign. So we're going to go back to the x value. Oh, and also in vertex form, your x was equal to h right there. So the reason why it's opposite is because that negative symbol, and that's the reason why we're going to be using the opposite sign in our vertex form. So if we look here, this is where our h would be. It's a negative 3, so it's actually going to be a positive 3 of our axis of symmetry. And then we are going to now use that, it's our x value as our vertex. Well, the k is also this value. That value stays the same as a positive 5. So that's the value of our vertex and our standard form. It's going to go in the center of our graph because we now get to figure out the rest of the values. So while you're setting up your table, you're going to do numbers less than 3, so 2 and 1, and then numbers greater than 3, 4 and 5. Now we're going to plug in these values into our equation to see what we get for our y values. So y equals, we have our x, we're going to plug in 1 for x this time, minus 3 squared plus 5. And this was a plus 5. I just marked over it. So now we're going to go ahead and do y equals, in parentheses first, 1 minus 3 is a negative 2. So then we have to do negative 2 squared, which is going to be a positive 4. And then we have plus 5, so we get y equals 9. So that's going to be our y value for when we plugged in 1. And that's hopefully going to be our number 5. I'm just going to plug in 2 though. So I have 2 minus 3 squared plus 5. And we get 2 minus 3, which is a negative 1 squared. And now we're going to square the negative 1, which is a positive 1. 1 plus 5 is 6. Okay, now we're going to go ahead and finish plugging in those other values because we want to make sure that they really do equal the same values that they would of being 6 and 9. So we're going to plug in the 4 first. So I have y equals 4 minus 3 squared plus 5, and then now we have 4 minus 3, which is a 1. 1 squared is 1, so 1 plus 5, we get 6. So yay, it is repeating itself. And then y equals a 5 minus 3 squared, and we get plus 5. 5 minus 3 is 2, and then 2 squared, we get 4. So 4 plus 5 is 9. Yay. So it does repeat. We did our correct work. If we have our axis of symmetry going through x equals 3, that's where we know our reflection points are going to go. So we're going to go 1, 9. So I have 1, 9 here. 2, 6 is here. which means our vertex should be right on that line, 3, 5, and it is, yay. And then it should repeat at 4, 6, and then we have 5, 9. So again, it should be mirrored across the axis of symmetry. This is a positive parabola because we didn't have a negative in front of those parentheses. So if it's positive, then we have the happy face parabola. All right, you guys, we'll see you next time.